Hello, my dear students. I'm Dr. Vaishaly Bharambe. I've been teaching anatomy for the last 25 years and I love it. There's so many images you're seeing on the screen. Each of them seems to be some kind of a bar, isn't it? It's a bar, there's a bar of chocolate, there's a bar with some kind of gym happening here. So, what is it? It seems that we want to talk about a bar today. Yes? Yes. The topic for today is Barr Body and Lyon Hypothesis. Students, this is a very common short note asked for students and therefore we need to understand it. You may know a little bit about Barr Body, I'm sure it was taught to you in your school years, but to really understand it, that's what medicine is all about. Okay, so let's dive in. Right. So this is a little story we begin with. What happened long time ago in 1949? There was a scientist Barr and Bertram, and they began to study the neurons of female cats. And what did they find? They found that there was in the nucleus of this neuron, there was a chromatin dense body. Okay, take a look. This was the chromatin dense body, which they called as sex chromatin. Now, why did they call it sex chromatin? They called it that because it had a predilection to a particular gender, namely the female. Yes? So, this sex chromatin body was found only in female cells. They studied other cells as well, in female cats, in female other mammals, and every time it was the female which showed presence of this tiny little chromocenter, which they called as sex chromatin. Okay? So, what is sex chromatin? It's a small dense body found inside the nucleus of female mammals, discovered in 1949 by Barr and Bertram. Okay, so in which tissues can I find it? Can I find it in every tissue? The actual availability or appearance of this is variable in different tissues. For example, you can have it in nerve cells, amniotic fluid, chorionic epithelium quite often, with somewhat less appearance seen in oral smears, vaginal smears and so on. Okay, right. So question is, what does it really look like? I said it was a chromocenter. Remember, the most important part of today's discussion is it is found inside an interface neuron. You will not find it in a dividing cell. You will find it inside an interface nucleus only. Okay, and then what does it look like? It looks like a small chromocenter which is heavily stained with basic dyes. इसका मीनिंग क्या हुआ कि हम जो H&E stained cell देखते हैं, the H&E stained cell that you see, okay, inside the nucleus of that, you will find something that is looking even darker. Okay, that dark basic stained tiny little chromocenter is the sex chromatin. Later on also began to be called as the Barr body, for obvious reasons because of the scientist Barr. Okay, so what are the various positions inside the nucleus that you may find this object in? Okay, is it always found in the, as I had shown you in the earlier diagram, or can it be found in different positions? Okay, for this I want you to draw to understand. I will draw and you will draw with me. Okay, let us begin by drawing a nucleus. The Barr body can be found attached to the nuclear membrane. It can be found attached to the nucleolus as seen here. It might be found floating around in the nucleoplasm. This is the neutrophil leukocyte. Draw the multilobulated nucleus here. Draw an extension from it in this manner. This extension is called as a drumstick and is also a representation of Barr body. Right, so let's revise now. So as you saw, the sex chromatin can be found attached to the nuclear membrane. It can be found attached to the nucleolus, floating around in the nucleoplasm, or it can also be found extending out from the nucleus in the form of a projection which is called as the drumstick. Which cell is this? Neutrophil. Very nice. So, it isn't that you only find the sex chromatin. You find it in variable positions inside variable cells. Okay. So, how will you study the Barr body? Where will you take the tissues from? Yes, I told you that you can take it from amniotic fluid, chorionic epithelium, and so on. But remember that the availability should be that much. It should be easy to get that tissue. So most commonly we are using oral mucosa. Okay, you just take a little tissue from the oral mucosa, study it for presence of Barr body. Versus you can also use blood and amniotic fluid for studying for a Barr body. Now you take that tissue, stay in the slide, and look for a presence of a sex chromatin. Question is, why am I doing all this? Why, madam? Why are you taking tissue? You know, okay, there's a Barr body inside the female nucleus. How does it matter? How does it help us? It helps us because, now you just imagine that there is a patient who's come with ambiguous genitalia. Looking at the genital region of that child, you cannot tell whether the child is a male or a female. I'm sure by now you know that such babies are born routinely. So now, whether to call this child as a female or a male is a big question. The parents are obviously completely confused. What is to be done now? Simple. Just do a Barr body test. If you find that there is a Barr body in the cell, then you know it's a female. And versus no Barr body, likely to be a male. That easy and that useful is your Barr body. Now there's a second point I want you to observe. Detection of sex chromosomal anomalies. Now how does that happen? How do we detect an anomaly? Fine, I can tell male, female. That was understood. How can I tell whether the person is having an anomaly? Okay, so I'll tell you that for understanding this part, you need to study something called as Lyon Hypothesis, which is the next part of today's discussion. Right. So let's understand Lyon Hypothesis and the principle of X inactivation. Okay. After that, I will explain to you how a Barr body can help you to understand sex chromosomal anomalies. Okay. Right. So before we go into the rest of the class, I want you to quickly revise Barr body. What did we learn? We learned that there were scientists called Barr and Bertram in 1949. They saw presence of a sex chromatin inside the female neuron, okay, of a female cat. They called it the sex chromatin. We know that this sex chromatin can be found in all female mammals. Its availability is variable in various tissues. Like I can find it very often in amniotic and chorionic epithelium. Comparatively less often I can see it in oral mucosa cells. These are the tissues which I can take for studying the Barr body. Then we drew the diagram of positions of Barr body inside the cell. Remember, if you draw, you remember. So do please draw when I do my diagrams. It will help you to register this in your brain. Finally, we also discussed how sex chromatin helps to identify the sex in case of children who are born with ambiguous genitalia. Right? Now to understand how it helps us to understand sex chromosomal anomalies, we are going into the topic of Lyon Hypothesis. Alright, are you okay with this? Let's go to the next part of today's discussion. Before that, if you're enjoying this lecture, students, kindly like and subscribe. I will at least know whether you are enjoying my lectures or not. Okay? Thank you so much. So, Lyon Hypothesis. You will feel Madam keeps on telling us stories, but Lyon Hypothesis is another story. I hope you enjoy it. What happened was there was a scientist called Mary F. Lyon. In 1961, she came up with her hypothesis called as X chromosome inactivation. Now, can you understand the chronology of events? 1949, Barr comes up with sex chromatin. 12 years later, Mary Lyon comes up with the explanation of sex chromatin by her hypothesis X chromosome inactivation. What does she say? What was her hypothesis? Her hypothesis statement was, in a somatic cell, in female mammals, in a somatic cell in a female mammal, only one X is active. The other X chromosome is inactivated and condensed and appears inside the cell in the form of a chromodense body which is called a sex chromatin. So the question that was raised by Barr body, that there is a sex chromatin, we don't know what it is, was answered by Mary Lyon when she said that I know what it is. I know it is the second inactivated X chromosome of any female. Got it? Now we understand that sex chromatin is an inactivated X chromosome of female mammals. And this process of X inactivation is called as Lyonization in the honor of Mary F. Lyon. Okay, so you got the chronology of events and the story behind it? Okay, so when does this inactivation occur? This is a very important sentence I am putting in here. This inactivation occurs at 15th to 16th day of embryonic life. So it is not that you are born with an inactivated X. You are having an inactivation on the 15th day post your conception. Please can you repeat this with me? In embryonic life, on 15th to 16th day of gestation, the X chromosome gets inactivated. Okay? Right. This you have to keep in your brain because after I discuss some more, we're going to come back to this sentence. Now I have another question for you. Which X gets inactivated? I've got two. So how do I decide which one? One X I've got from my father, one X I've got from my mother. Which one should I get inactivated? The answer to this is this inactivation is completely random. Okay? Whether it's a maternal or whether it's a paternal X is getting inactivated, it's a random decision. But once the decision is taken, the same X gets inactivated in the series of cells that come from that cell. So, a person may have in some of his cells the mother's X is inactivated. In some cells, it's the father's X which is inactivated. However, the decision of X inactivation in those cells and their progeny will be constant. You cannot say today I have my P inactivated and tomorrow I want my M inactivated. No. Right. So we've understood what is X inactivation. We know that it was a Mary Lyon's hypothesis. We asked ourselves, when does it get inactivated? And we learnt it gets inactivated from 15th to 16th day of embryonic life. We also learned that this X inactivation is completely random. Okay? Now relax. We're getting into the more interesting part of our class. Maybe you can have a sip of coffee or maybe you can have some water. Just relax and understand. Okay? So I'm also going to have some coffee. Right. So let's now go to some features of Lyonization. The first feature is the obvious one, that every female has one Barr body. Every female has one Barr body. Why? Because she's got two X chromosomes. So one is going to get inactivated. Think where we are going. There is a formula for calculating anybody's Barr body which goes as follows. Nx minus 1 is equal to number of sex chromatin in a person. Nx is the number of X. So I've got 2X, therefore 2X minus 1 is equal to 1. So I have one Barr body. This formula is something you need to learn up. Okay, it doesn't take too much intelligence to learn, thank God for that. Right. So what's the next feature of Lyonization? We've covered two. One is that female has one chromatin and second is there is a formula to it. The third feature is if a person has only one X chromosome, the person has zero sex chromatin. This is actually the same thing. We're just trying to put words to the formula. If the person has only one X chromosome, the person has zero sex chromatin. Who is that person you know who has only one X chromosome? Obviously the famous male human being, right? So the male human being has got one X and one Y. Apply the formula to it. 1X minus 1 is equal to 0. So how many sex chromatins do males have? They have 0 sex chromatins. Okay, have you understood that? So in a male there is only one X which is active. So there cannot be a sex chromatin. Fine. Finally remember that Barr bodies are absent in gametes. Why are Barr bodies absent in gametes? Because the gametes have only one set of chromosomes. They don't have pairs of chromosomes. In one set, there is going to be max 1X. So 1X minus 1 is equal to 0. Right. So we've done 5 features of Lyonization. Now I want you to work something on your own. Okay. So this is a worksheet for all of you. I want you to take a look. X normal female. So apply the formula. 2X normal female. So 2X minus 1 is equal to 1. This is how a normal female will have one sex chromatin. Now use the same method. XY normal male. He's got X chromosome, he's got a Y chromosome. How many X chromosomes? 1. So 1x minus 1 is equal to 0. So that is why the male has got 0 sex chromatin. Right? Now let's come to something a little more interesting, students. Let's have some fun. Now I'm talking about the Klinefelter syndrome. XXY. Here is a person who looks like a male, was brought up like a male, and for some reason he's come to you. When you do his Barr Body test, you find that he's got a sex chromatin. 2x minus 1 is equal to 1. So there is a big question now. How come there is a male who looks like a male and he's having a sex chromatin? It raises the question of, does he have a sex chromosomal anomaly? Have you understood how the Barr Body is now taking us gently towards identification of sex chromosomal anomalies? This is how it works. Right. Let's talk about another syndrome, the Turner syndrome. Now recall what you know about Turner syndrome. You know that Turner syndrome has one X only. XO is Turner syndrome. Now let's put the formula to it. So 1x minus 1 is equal to 0. That's actually very alarming, because here is a girl who looks like a girl, was brought up like a girl, and ideally, therefore, she should be having a sex chromatin, but she doesn't. Now, you know that here, this is a case of sex chromosomal anomaly. There lies your answer. What are the uses of Barr Body? Uses of Barr Body is identify the sex of the individual and identify sex chromosomal anomalies. Not only it is of this use, student, this formula and this worksheet is useful to you because this is a standard MCQ asked. What is the number of Barr bodies found in Klinefelter syndrome or Turner syndrome? So you need to know all this because you also need to solve your MCQs. Have you understood how Barr bodies help you? Okay? Right. Then with this, let's come to something a little more interesting, which will make you really begin to think about X inactivation. There is something called as preferential X inactivation when we know very well that X chromosome inactivation is random. Yet I am saying that there is something called preferential X inactivation. Between the two X, one gets repeatedly inactivated. Okay? This is also called Skewed X inactivation. What is this? Somewhere down the line you have been reading about this, but at this moment you cannot really tell what is ma'am talking about. See, basic principle is that in X inactivation, that X that multiplies first will remain active. That which is slow in replication will become inactive. Actually, this is true to life also. Those who are fast go ahead in life, those who are slow get left behind. Simple logic. Same thing is applying to human body as well. Right. So when do you see skewed X inactivation? When a X is affected by deletion or some other abnormality, then what happens? Human body tries to inactivate it. This X is not normal. Let me inactivate it. So that is how some X's are preferentially inactivated compared to the other X in the body. How can I understand this? How do I know there is some kind of abnormality in the X? See, again we come to Barr Body. The Barr Body looks abnormal. It may be over large, it may be very small. That's how you can tell from the shape of Barr Body the abnormalities in the chromosome. You must have heard about this when you read about the isochromosome X or even ring X for that matter. These result in very large sex chromatin. Okay? So, and they are preferentially inactivated. Right. Is there any other example of preferential inactivation? Yes, this one I like even more than my early example. Just imagine that you have an X chromosome and that X chromosome, I suppose this is my X chromosome, okay? And I've got a bit of another chromosome translocated on it. So my X is there and I've got an autosome translocated on it. Can I do without my autosomes? I can't. The body cannot do without autosomes, right? So what does the body do? It inactivates the normal chromosome and keeps this one which has got a translocation working preferentially. Why is that so? Because you cannot have inactivation of an autosome. Have you got the logic behind it, students? Okay, right. So sometimes, of course, there are families in which some X's are routinely inactivated. So this is a genetic matter which we cannot really put any logic to it. That's how it is. So we saw there is something called preferential X inactivation. If the X is abnormal, okay, it gets preferentially inactivated. If the X has an autosome translocated on it, then that X remains active. Okay, right. So I have some questions in my mind because of which I feel I do not agree with Lyon hypothesis. The world has them too. The simple question is, if X in double X chromosome, like me, if one X is anyway inactivated, why am I not equal to an XO? Why is XX not equal to XO? Again, if the male has got one X chromosome active, okay, and in XXY, Klinefelter syndrome, also one X is active, then why is an XY not equal to XXY? Why do Klinefelter's and Turner syndrome look different? Right, they do look different, isn't it? So the explanation here is the same sentence that I asked you to remember earlier. The X inactivation takes place on 15th to 16th day of embryonic life, right? So it is probable that till the 15th to 16th day, the X chromosome was active. Both X chromosomes were active. They were helping to set up the basic of female sexual development. Once that basic is set up, the X goes into inactivation. And that is why that female develops as a female, whereas a Turner syndrome does develop some features of female but lacks many of them. And that is why she as an XO becomes a Turner, whereas a normal other female with double X becomes what they become. Right? There's one more explanation is maybe the entire X is not inactivated. Maybe a part of it determining the development of differences between XO and XX remain non-inactivated, and therefore there lies a difference. So let's do what we discussed. Let's quickly revise what we discussed just now. The question I had posed before all of you was, if one X is inactivated, then why is an XX not equal to XO? If one X is inactivated, why is an XY not equal to XXY? The possible explanation lies in the fact that probably till the 15th day of intrauterine life, the X remains active, resulting in certain development of female characteristics which result in development of a normal female or which result in development of Klinefelter's syndrome. Another possibility is that the entire X is not really inactivated, right? So these are some of the challenges that have been posed before the Lyon hypothesis, right? Now another last question I place before you is, what is Mosaicism and how is it related to Lyonization? The answer is that Mosaicism is a condition when a person is having two cell lines in the same genetic makeup. In the same human being, there are two different cell lines, right? Now, human female is a normal mosaic. How? I just told you that in a human female, at some point decision is taken that in these group of cells, the maternal X is active. In these group of cells, the paternal X is active. So you saw that how there are two separate lines of cells with two different chromosomes remaining active in the same female. So the human female is a natural mosaic. Right. So let's revise what we learned today. We learned about the story of Barr and Bertram 1949, how they came up with the sex chromatin, how they spoke about its appearance, then we discussed its position, how do we study Barr body and what are the uses of Barr body. Then we began our discussion on Lyon hypothesis. Who was Mary F. Lyon? In 1961, she came up with her X inactivation hypothesis. When does X chromosome undergo Lyonization? Which X will be inactivated? The formula for sex chromatin. And what was Skewed X inactivation? Our worksheet, of course, which I want you to revise once. And finally, why is XO not equal to XX? Why is XXY not equal to XY? That's what we have discussed. Yes, we've discussed what is Mosaicism as well. Students, I have some amount of reading I want you to do on your own, which is beyond the purview of my short lecture. I want you to read about what are the indicators, what is the evidence that Lyonization really exists. There is proof. Read it. What is Chimerism? How is it different from Mosaicism? Okay, now I have put up some notes for you here and here. I want you to look at those. I want you to maybe take pointers from this for answering those questions. Alright, if you have problems, you can always contact me or put your problems in the comment section. I'll come forward to explain them to you. Right. Students, if you've enjoyed this lecture, do please like and subscribe to the channel. Do share your thoughts in comment section. I really need to know what is working for you and what is not working for you. Right. So some MCQ, see if you can solve them. The number of Barr bodies seen in Turner syndrome is? Students, if you cannot answer that, then I am absolutely a terrible teacher. X chromosome inactivation is known as, obviously, Lyonization. Okay. So, there are a lot of bars in medicine. One is a Barr body. The one is an Epstein-Barr virus. There's in Guillain-Barré syndrome. You need to know them all, students. But there is one more bar which is really fun. Yes? Life is like a bar of chocolate. You never know how sweet it is till you take a bite. So enjoy your life, enjoy your studies. Whatever you do, do it with fun. So maybe the knowledge will stay in your mind better. Right. Had enough of bars, I think. So let's move on to chromosomal anomalies next time. The link for those lectures is given in the description section. Chromosomal anomalies will be structural and numerical. All of them come as common short notes for all of you. Do please go and see those lectures as well. Students, I loved taking this class. The Lyon Hypothesis is a particular favorite of mine. Okay. I hope you enjoyed it too. See you across the screens in some other lecture. Thank you.